அனைவருக்கும் வணக்கம். I am Sherlin, Standard 7, studying Noordanai Girls Higher Secondary School. I am also a student of Junior IES Academy.
Welcome friends. Pleasure morning to all. Today we are going to discuss about Standard 7th Science Atomic Structure. The topic is Atomic Structure. Part 1. Everything in this world is made up of tiny particles. The amount of particles that go into making different product may vary, but every object will have atoms as its smallest building block. The structure of an atom, everything in this world is made up of tiny particles. The amount of particles that go into making different products may vary, but every object will have atoms as its smallest building block. So, what is an atom? Now let's fast forward to the late 800s when things changed when Sir J.J. Thomson accidentally discovered the electron. That happened while he was conducting experiments using a cathode ray tube. Now before going further, first let me tell you what the cathode ray tube is. A cathode ray tube is a vacuum sealed tube that does not allow air to enter it. Now inside the tube on one side a cathode is placed and on the other side anode is placed unit. So some new terms is it. Now before start wondering, the cathode is a negatively charged conductor and the anode is a positively charged conductor, and the anode has a small hole and its opposite wall of the tube is coated with fluorescent material from the inside. Got it? Back to the Thomson's experiment. So, in a dark room, when an electric current is passed through a gas at high voltage and low pressure, he found out that a stream of minute particles is let out by the cathode, and the small hole on the anode allowed this beam of light to pass through it. And when this beam struck the wall coated with fluorescent material, it started to glow. Wow, that's fascinating wood. You say from this he decided that these particles must have come from somewhere within the atom, and that Dalton was incorrect in stating that atoms cannot be further divided to smaller pieces. Now let's take a closer look at what happened inside the cathode ray tube. When a high electric current is applied, the electric energy pushes out some of the electrons from the gas, these fast moving electrons from cathode rays. Thomson never set out to discover electrons with this cathode ray tube experiment, but while this experiment he stumbled upon this discovery, and that's why no one called it an electron beam back. Then instead what flowed out of the cathode and travelled towards the anode was called a cathode ray. So this is how J.J. Thomson discovered electrons. So that was all about how electrons made a grand entry in a world of science. Now let's take a look at how protons came to the fore in 1886. E. Goldstein, while performing some experiments with a discharge tube containing perforated cathode, observed that when the cathode rays are traveling from the cathode to the anode, there are some luminous waves which travel from the anode to the cathode, and he called this canal rays. Why that name, you wonder? Any guesses? Simple. Since these rays passed through the holes of the cathode, he named them canal rays. With his experiments, he found that these rays are made up of another subatomic particles later labeled as proton. Rutherford. These rays are also called as anode rays, as they emerge from the anode and they travel towards the cathode. So it becomes necessary to find out how these electrons and protons were arranged inside the atom. But do remember that the third subatomic particle, neutron, had not been discovered at that time. We are talking about the late 1800s, when only electrons and protons had discovered. So all the atomic models that were studied only contained protons and electrons. The first attempt to describe the internal structure of an atom was done by Sir J. Thomson. He went one step further and proposed the model of an atom to be similar to that of, you will never guess what I am going to say. He suggested that this was similar to that of a Christmas pudding. He stated that negatively charged electrons needed a positive charge to balance them. How? So, he determined that they were surrounded by positively charged material. Now, this came to be known as the Plum model of the atom. Have you tasted it? I love plum pudding. Anyways, moving on, this basically means that the negatively charged plums were surrounded by positively charged pudding.
In this video, Standard 7th, Science, Atomic Structure. What is structure of the atom? What is model of the atom? And what is plum pudding? In detail. And next, we see in the next video.